Let's go to Liquor 310 minimal height trees. Give us integer n means this is a tree and it has node from 0 to n minus 1. It also give us integer array ages. So so the things that we want to find um, a list of minimal height tree root labels. So what does this one mean? You see, example one, if we have root at one, it will have a height only one. And for other nodes, if they are root, they will have a root as two. So this one will return one. In the second example, when we have root at 3, it will have a height. So what is height? Is from to the longest leaf, right? So the height with 2. If we have root with 4, so it will also have the height to be 2. So we return two nodes, 3 and 4. So let's return a list of integer. So if we look at the shape of those trees, right? So we'll find this one is return one. Um, we'll see this one is actually in the center of this tree. That means if we get rid of those tree nodes, for example, 0, 3, and 2, right? Then we'll leave this as 1. So it looks like we are getting out some of the leaves and can do layer by layer. So we'll see if we get outside, then what we left in the end, it will be the result. So let's try to apply this logic to our example 2, right? So what is the outside? So for the outside, we'll see the tree nodes which only have one connections, right? So this one are outside, outside, outside. So when we get rid of this, what we left is 3 and 4, right? So we'll see it returns 3 and 4. So this kind of doing like a dependency uh, in the then go to its child, those kind of things. What I was thinking about is doing something like the topological sorting, right? But for this one, when we consider topological sorting, is that we in Q is that all of the nodes because here there is no direction, right? So no direction. Or we'll see they are bidirectional. We can consider as bidirectional, right? So in this case, how can we have those kind of dependencies? We will not have integrity equals to 0, but we'll get rid of the in Q, have a Q, right? In Q, those nodes which have integrity equals 1 first. So when we get this one, we'll see 3 initially as integrity 1, 0 as integrity 1, 2 has integrity 1, right? But 1 has integrity 1, 2, 3, right? So but the thing is that this one will never in Q anymore, right? So let's look at example 2. Let's look at the example 2. So we'll see this one has integral 1, this one has integral 1, this has integral 1, right? This has integral 1. So in the end, we left 3 and 4. 3 and 4 have integral 1, right? Both have integral 1. And in the the example 2 is that when we left only one node, it have integral 0. So the thing is that our in the end, So we can have the assumption that we'll get if those kind of tree nodes they have integer one, right? Then we are able to enqueue. Um, and then we get the rest child the integrate each will decrease by one, right? And also um here we should do layer by layer, right? That is another thing. Is that one is we should have integrate equals one, then we are able to enqueue. Another is we should enqueue layer by layer. So um, if we have in the end, um, we can have a total n, right? If we have in the end what we have the node we can use a remain variable. If we enqueue some nodes, we'll have n minus something. Every time we'll have the initially remain equals n, right? Every time a node is enqueued, will remain minus one, right? So if we have remain small equal than two, right? Then what we left will be the result. So we can use our remaining variable to do this. So let's write code for this, implement our logics. So we'll see if n equals 1, right? That means there is only one node. We just list of 0. And also if n equals 2, we just return list of 0 and 1, right? Then we can from our edges to build graph and integrate map. So our graph we can use a list of integer array, right? Because the n is already given plus new list, and so we can have arrays set for graph k goes to new array list. And what about the integrates? Integrates, we can have this, just have an array, right? Because new int. And then let's compose graph, right? For age, in ages. So we're going to have graph age 0, add age 1. And also we're going to have this age 1 at age 0, right? And also in degrees, age 0 should increase, right? In degrees, age 1 should also increase, right? Yeah, what we do, we can use a remain variable as we say remain equals n initially, right? So, mm, so we can have a q, right? So q uh, integer q equals new array that. So what we do is that we just have those integers equals to 1 to put into a queue. For int I equals 0, I smaller than n, I plus plus. Therefore, in degrees I equals 1, then we're going to have Q over I. So in our while place, why this Q is not empty? And remain greater than 2, right? So we are going to have input size equals Q dot size. Then for int I equals 0, I smaller than size I plus plus. So we'll do layer by layer, right? So after this layer, we're going to have remain minus equal to size. Right? So then we do layer by layer. So for this year, layer is int current equals Q dot pull. So then we are going to look at its chart for int next at graph parent. So we're going to have in degrees next, which is decrease by 1, right? So if in degrees next equals 0, then we're going to enqueue, right? Equals 1, sorry, this is for this question, it should be 1. Then we're going to have Q offer next. So Um, so the thing is that if Q size is small equal to 2, right? We are jumping out of the while loop. So in that case, what we left in the end when we jumping out of the while loop, we have nodes either 1 or 2, right? So what we do is that we're going to have a list of integer results equals new array list. Then for interview in queue, result add with event the return results. Do you like this? So every node will be in queue once, right? Um, and so the time complexity will be O(n), and the space we are having, we are using, for example, this list like a map, right? This is linear. This integer is also O(n), right? And for our queue, we'll see it is every time we are going to put in a layer, right? So the worst case, the layer, for example, it can because it may have different shapes, right? The worst case, the layer like uh, like a lot, right? So it is possible also in this case, right? We'll put n minus one into the for the first layer. So it is still also an so the time complexity and space complexity are both O(n). We're going to write a Python code for this as well. So let's see if n equals 1, return 0, and if n equals 2, return 0, 1, right? Then what we do is that graph equals to default dict list. Then in degrees equals this one. Let's use an array, right? For u, v in ages, then we're going to have graph u append v in the graph v append u, right? In degrees, u should pass equal to 1. In degrees, v should pass equal to 1, right? Then we are going to have q. So we're going to have q equals d deck. So I see I for I in range n if in degrees I equals 1, right? And we can have remain equals n. So while this q is not empty and remain uh, greater than 2, so size equals the length of q. And what we do is that for this one in range size, we're going to have current equals q dot pop left. And for neighbor, next neighbor in graph for current, we're going to have in degrees neighbor should minus equal to 1, right? If in degrees neighbor equals 1, we're going to have q append neighbor. In the end, when we jump in out of this while loop, right? So the what in the queue it may have 1 or 2 items, just return list of queue. Let's take a look. So if this is default integrate u and v q equals if this one equals 1 and the remain equals n, while q and the remain greater size equals length of q. For this one, we didn't. Every time we have follow up, we should have this size remain, right? Remain minus equal to size, and okay, so this will be the code.